Welcome back. This is section 3.1, quadratic functions and models. So what we're going to look at in this section are the different forms of a quadratic function, what those different forms can tell us about the graph of a quadratic function, and then also how we can use quadratic functions to model real-world situations. All right, so first off, a quadratic function is any polynomial function of degree 2. That means that the highest exponent on your variable x is going to have to be a 2. So notice here we have ax squared plus bx plus c. X squared, that is your highest exponent on your variable. Therefore, this is a quadratic function. Now notice here it says that a cannot be equal to 0 because if you put 0 in front of the x squared term, it would go away and you'd no longer have a quadratic function. Okay, so we have to have some coefficient other than 0 in front of the x squared term. But as long as you do, and that's your highest exponent, then we have a quadratic function. Right, now, standard form of a quadratic function. Another name that you might see for this is vertex form. Okay, so if you ever see either one of those things in the context of our textbook, right, they mean the same thing. So standard form or vertex form. We're going to take the ax squared plus bx plus c form that we just saw on the last slide, and we're going to rewrite it in this form, a times x minus h squared plus k. So this form right here is what we call standard form or vertex form. Now, the way we're going to get it into that form from the previous form is we're going to complete the square, right? And so you have to think back to the way we did that back in chapter 2, right? When we completed the square, we're going to use that same process here to get our quadratic function into this form, because then that's actually going to give us the vertex of our parabola, which is what the graph of a quadratic would look like. Okay, and so the way we're going to get that vertex at that point is by looking at the h value and the k value, and that's going to give us the ordered pair that is the vertex of our quadratic function. Now, if a is greater than 0, then we're going to open upward. And if a is less than 0, then your quadratic function, your parabola, is going to open downward instead. Right? And you can see that on each of the graphs here. Okay, so in both cases, the vertex is hk. But then if it opens up, that means that the a value is greater than 0, a positive value. If the a value is negative, less than 0, then it's going to open down instead. That's why we like this form, is it tells us a lot about what that graph is going to look like. All right, so first thing we want to do here is take this quadratic equation, rewrite it in standard form or vertex form. All right, now the way I'm going to do that, I'm going to go ahead and just change f of x to a y. So we have y equals 2x squared minus 12x plus 13. All right, and if you remember back to completing the square, the first step here is we're going to take that c value, the plus 13, we're going to move it to the other side. So I'm going to subtract it. So we're going to get y minus 13 equals 2x squared minus 12x. Okay. Now, if you have some value in front of x squared other than a 1, in this case we have a 2 there, the next step in completing the square is we have to factor out whatever factor we have there. So I'm going to factor out the 2 this time. We're going to have y minus 13 equals 2 times, that's going to leave us with x squared minus 6x. Notice I did not factor out the x, I only factored out the 2. Okay, so only factor out the number part, not the variable. All right, now at this point, now we can use our formula for completing the square. And so if you remember, that's b divided by 2 squared. In this case now, the b value is that negative 6. Okay, so it's the term, the number coefficient in front of your x term. So we're going to have negative 6 divided by 2 all squared. Now we simplify. Negative 6 divided by 2 gives us negative 3. And if we square that, we're going to get 9. Now that gives me the new c value for my quadratic so that I can complete the square. So that means I'm going to come over here and I'm going to add 9. But remember, whatever we do to one side, we have to do to the other side of the equation. Be careful here. We didn't just add 9, we added 2 times 9 because we have that factor of 2 on the outside of the parentheses now. So what I'm really adding over here now is 18. And again, that comes from the fact that we have the 2 on the outside of the parentheses. 2 would get distributed to the 9. 2 times 9 is 18. That's why I had to add 18 to the other side. Now we simplify. If I combine like terms on the left, we have an 18 and a minus 13. That's going to give us 5. So we have y plus 5 equals. Now we can actually factor the x squared minus 6x plus 9. So when we do that, remember this is a perfect square trinomial. This is actually going to factor into x minus 3 squared. Now the easiest way to get that term that's going to go in your factor is to look right back here at whatever number we had before we squared. That's going to tell you what to put in there. We had a negative 3. That tells us our factor is going to be x minus 3. And then our last step, we just need to move the 5 back to the other side now. So we're going to have y equals 2 times x minus 3 squared. And then we're going to subtract 5 to move it back. That would be our standard form now of this quadratic, because remember the standard form is a times x minus h squared and then plus k. All right, now the second part of this one says we're going to find the vertex. Well, the vertex here, remember, is just the h and k value from our standard form. So I'm just looking at the value inside the parentheses and then that number down at the end there. The number inside the parentheses, we're always going to take the opposite. So in this case, we have a minus 3 in there. That tells us our h value for our vertex is actually going to be a positive 3. The k value, which is the number on the outside at the end there, is always going to keep its sign. So we have a minus 5. That means the k value is going to be a negative 5. So our vertex this time is going to be positive 3, negative 5. That's the point where our vertex would be located. All right, now we want the x and y intercepts. Okay, so if you remember, to find an x-intercept, we're going to substitute 0 for y, and we're going to solve for x. I'm just going to plug in 0 here. I'm actually going to substitute it in to my factored form in my standard form over here. So we're going to have 0 equals 2 times x minus 3 squared minus 5. So then I just need to solve that for x. So I'm going to move the 5 over. So that's going to give us positive 5 equals 2 times x minus 3 squared. Now I need to divide by the 2. So that's going to give us 5 halves is equal to x minus 3 squared. Now I'm going to take the square root of both sides. So when I do that now, we're going to get plus or minus the square root of 5 over 2 is equal to x minus 3. And then finally, I'm just going to add my 3 to the other side. That'll give us 3 plus or minus the square root of 5 halves is equal to x. Now, if you want to rationalize that denominator so that you don't have a fraction under your square root, we can definitely do that. We would just need to multiply top and bottom by square root of 2 here. So that's going to give us 3 plus or minus the square root of 10 over 2. And that's going to be our x value. Okay, so those are the x-intercepts of that graph now. Now, for the y-intercepts, we're going to plug in 0 for the x value and then solve for y. The easiest place to do that is back in the original equation, right? So I could plug it into the factored form, right? The standard form, that's perfectly fine. But it's actually going to be easier if we go back to the original this time. So if I do that, I'm just going to have y equals 2 times 0 squared minus 12 times 0 plus 13. Now, looking at that, if we simplify, all of those terms are going to go to 0 except for the very last one. And so this is just going to give us y equals 13 for our y-intercept. All right, now in terms of sketching the graph, I'm actually going to go into Desmos, right? And we'll look at this graph together just to see what it looks like. All right, so our original equation here, we had y equals 2x squared minus 12x plus 13. And so what I'm going to do is I'm going to check to make sure that all of our values that we found actually make sense now. Okay, so if we look first at our vertex, I can just click on the vertex. There's that +3, -5. That's the vertex that we got when we put it into standard form. Okay, so that checks out. Now, if I look at my x-intercepts, those were irrational numbers, right? We had 3 plus or minus the square root of 10 divided by 2. If I were to check the decimal values of each of those, you would see that they actually match up with these decimal values that we get for our x-intercept. Okay, so those x-intercepts do look good. We found the exact values using algebra. If you look at the graph, you're only going to get the decimal values, right? But if you check the decimal values of what we got, they should match those decimal values there. And then finally, the y-intercept, right? I'm going to have to zoom out a little bit so I can actually see where this crosses the y-axis. If you look right up here, there's 0, 13. 13 is what we got for the y-intercept, so that does check out. And then the last piece of this, right, is that our a value was a +2 once we completed the square. Positive means it's going to open upward, and so that's exactly what we have here, right? So based off of what we got in our equation now, we have a +2 for the a value, we have a parabola that opens up, we have a vertex at 3, -5, that checks out. Our x-intercepts that we got exact values for, those check out with where it crosses the x-axis, and then finally that y-intercept, +13, is indeed where it crosses the y-axis. So that's a good way to kind of check yourself to make sure that the values that you found actually make sense in terms of the graph. Okay. And now the last piece of this was domain and range. So I'm going to leave the graph up here so we can talk about domain and range. First off, domain. There are no restrictions on what the x value can be this time, right? We have no fractions with an x in the denominator. We have no radicals. So in this case, x could be all real numbers. So we would say our domain is from -infinity to +infinity. Now, in terms of the range, if I look at the possible y values, notice here, all of my y values are above that vertex right there. So I look at the y value of the vertex, which is -5. It is included in my range because it's actually a point on the graph. I'm going to have bracket -5, and then everything above that means it would go to +infinity. So our range here would be -5 to +infinity, with the -5 being included in the range this time. All right, so I'm going to switch back to the notes so you can see what I wrote there for domain and range. There you go. All right, so our domain here again was all real numbers, -infinity to +infinity, and then the range this time was from -5 to infinity. And again, notice the -5 was a point on the graph, therefore we have to put a bracket because it's included in our range. All right, max and min values of a quadratic. So if we let f be a quadratic function in standard form, right, the vertex form that we just looked at, the max or min value of f occurs at x equals h. Then if we want the minimum or maximum value, we're going to find the value of k, which is just the y value of that vertex, and that will tell us the min or max value of that function. Now, if a is greater than 0, that means that our parabola is going to open upward, and that means that we're going to have a minimum value. Okay, so make sure in this case, if a is positive, the parabola opens up, therefore there's a minimum value, and you can see that on that first graph. If instead the a value is negative, less than 0, then we're actually going to have a max value because our parabola is going to open down in that case. So just be really careful because it's easy to get those backwards. But in this case, when a is positive, it opens up and there's a minimum. If a is negative, then it opens down and there is a maximum. Okay. And again, whenever you see the word value here, you always want the y. Okay, so that's what you're looking at as the vertex, but you only want the y value of that vertex in that case. All right, so let's take a look at this one now. First thing we want to do, again, is express it in standard form. So we're going to take 5x squared minus 30x plus 49, put it into that standard form using completing the square. Again, I'm going to start by writing this as y equals 5x squared minus 30x plus 49. Steps are the same. I'm going to move the 49 over first. So y minus 49 equals 5x squared minus 30x. Again, the next step is if I have a coefficient in front of my x squared, I need to factor it out. So I'm going to factor out the 5 here. And give us y minus 49 equals 5 times x squared minus 6x. Now I can complete the square. So I look at my b value. Again, it's negative 6 this time. So we're going to have negative 6 divided by 2 squared. When I simplify that, I get negative 3 squared, which is 9. That means I have to come over here and add 9 in my parentheses. But I have to do the same thing to the other side. This time I have a 5 on the outside. So remember, we're actually multiplying 5 times the 9, which means I'm really adding 45 to the left-hand side. All right, now I can simplify. 45 and negative 49 is going to give us a negative 4. So we have y minus 4. On the other side, we can factor that. It's going to factor the same way as the previous one, right? X minus 3 squared. And then finally, I'm just going to move my 4 to the other side. So we'll have y equals 5 times x minus 3 squared plus 4. So there's our standard form. Right, now, in terms of sketching the graph, right, you could put this in Desmos. We could look at the graph. I want to find that minimum value of f, though. So to find the minimum value, the first thing we have to think about is where is the vertex? Okay, so in this case, the vertex. Remember, we're going to take the h value, which is the opposite of whatever's in the parentheses here. So that's going to become a positive 3. And then the k value, which is whatever the number on the outside of the end is, that's a positive 4. Now, because this says minimum value, we only care about the y value in this case. So I look at my vertex, I look at the y value, and so my minimum value is 4. And again, the reason we know there's a minimum this time is because we have a positive 5 as our a value. That means the parabola is going to open upward, and therefore there's a min in this case. All right, so now we're going to look at this function, negative x squared plus x plus 2. Again, the first step is we're going to put it into standard form. So I'm going to rewrite this as y equals negative x squared plus x plus 2. I'm going to move my 2 over, so y minus 2 equals negative x squared plus x. Again, I have a coefficient in front of my squared this time. There's an understood negative 1. So the first thing I have to do here is actually factor out the negative. So we're going to have y minus 2 equals negative 1 times x squared. If I factor out a negative 1 here, that next term becomes a minus x. All right, so then we just have to complete the square. Notice here my coefficient, my b, is going to be a negative 1. We're going to have negative 1 over 2 squared. So when I do that now, that's just negative 1/2 squared. I'm going to square the numerator, square the denominator. It's going to give us positive 1 over 4. So now I know I'm going to add 1/4 to this side. And so be careful here. Again, we have that negative 1 on the outside. So rather than adding 1/4 to the other side, we're adding a negative 1/4 or subtracting 1/4 instead, right? So it's negative 1/4 being added to the other side this time. All right, now I just need to simplify. So I have a negative 1/4 and a minus 2. If we find a common denominator there, that's going to give us negative 8/4 minus 1/4. So this becomes y minus 9/4. Okay, so again, that's negative 1/4 minus 8/4 would be 2. And that's where we get the negative 9/4 this time. And on the other side, I have my negative 1. Now, when I factor, again, all I have to do is look back at whatever number I had in here before I squared. So that's a negative 1/2. We're going to have x minus 1/2 squared. And then my last step is just to move that 9/4 back to the other side. This time I need to add it. So we're going to have y equals negative x minus 1/2 squared plus 9/4. And notice there, I dropped the negative 1 and just kept the negative, right? If you want to put a negative 1 there, that's perfectly fine. Just a negative works just as well, though, right? Because the 1 would be understood. And again, you could sketch the graph using Desmos or a graphing calculator, right? So I'm not going to go through that step. But I do want to find the max value. Now, the reason we have a max this time is because our a value is negative. So remember, that means this is going to open downward. Therefore, there's a max value of our function. Again, all I care about is the y value of that vertex. So I'm only looking at this value down here, the k value. So now my max value is going to be 9/4. The reason I emphasize that word value is a lot of times in WebAssign, they're going to ask you for just the maximum or minimum value of a function. Make sure you're only entering the y value in that case, right? If you're trying to put the entire ordered pair in, it's not going to take it. All right, now, in addition to actually completing the square and finding the vertex, we actually have another formula we can use here to help us find the max or min value of a quadratic. So if you have it in this form, the ax squared plus bx plus c, we can actually use this formula here, x equals negative b over 2a, to find the x value, or the h, of our vertex, and then we can substitute that into our function to find the k value, or the y value. And again, if a is greater than 0, we're going to have a min. If a is less than 0, we're going to have a max. But the way we're going to find that max or min value now is we're going to say x equals negative b over 2a. Whatever we get for that x value, we're going to substitute back into the function, and that's going to give us our min or max value. All right, so we want to find the max or min value of each of these functions. So again, our formula here, we're going to start with x equals negative b over 2a. So for this first one here, our b value is 4. We're going to have x equals negative 4 over, and then 2 times a. Well, the a value this time is an understood 1. We're just going to have 2 times 1. Now, when I simplify that, that's just negative 4 divided by 2. That's going to give us negative 2. Now, again, that's not the min or max value. That's just the x value where the min or max would occur, right? It's the h value of your vertex. Now we're going to substitute that back into our function to find the actual min or max value. I have f of negative 2. That's going to be negative 2 squared plus 4 times negative 2. Now, if we simplify that, negative 2 squared is going to give us 4. 4 times negative 2 is a minus 8. And 4 minus 8 is going to give us negative 4. Now it's just a matter of determining, do we have a min value or a max value? Okay, so in this case, our a value, remember, is an understood 1 here. That's a positive value. Therefore, this parabola is going to open upward, and we're going to have a min value. So our min value for this one is going to be -4. So again, the reason this formula is useful, it prevents us from having to go through the entire process of completing the square if all we care about is the min or max value. All right, so we're going to do the same process here on g of x. So again, we're going to take x equals, if we do -b, that's going to be -4 again, over 2 times a. This time a is -2. 2 times -2. That's going to give us -4 over -4. So that actually comes out as a +1 this time. Again, that's not our min or max value. We still need to substitute it into our function. So now we've got g of 1 equals -2 times 1 squared plus 4 times 1 minus 5. So if we simplify that this time, -2 times 1 squared is -2. 4 times 1 is +4, and then minus 5. Combining all of that now, -2 plus 4 is going to give us 2. 2 minus 5 should be a -3. So there's our value. Again, the last step is just to determine, do we have a min or a max? Well, in this case, our a value is -2, right? Because we're looking right here at this value here. That tells us our parabola is going to open downward this time, which means we're actually going to have a max. We have a max value of -3. Be very careful there. It's really easy to see a negative value and think, oh, that must be a minimum. But in this case, right, you have to look back at what the parabola is actually doing. We have a -2 as our a value. That means it's opening down. Therefore, this is actually a maximum value of that parabola. All right, example 5. Most cars get their best gas mileage when traveling at a relatively modest speed. The gas mileage M for a certain car is modeled by the function, and we have M of S equals -1 over 28 S squared plus 3S minus 31. Notice here it tells us that our S values have to be between 15 and 70. Those are representing our speeds in miles per hour. And then the M value is a measure of the miles per gallon, the actual gas mileage. So what we want to find now is, what is the car's best gas mileage, and at what speed do we attain that best gas mileage? So we're looking for both the M and the S values where we have the best gas mileage. Well, if you notice here, our A value is a -1 over 28. What that tells us is we have a quadratic here because of the S squared, which is a parabola, and because of the negative A value, it's going to open down. That means that this is going to have a maximum at its vertex. And that's exactly what we want to find here. We want to find the best gas mileage and the speed where we have that best gas mileage, which means all we care about here is what is the maximum of this function. Well, we can actually use the formula we just looked at to find that. So I'm going to do S equals, instead of X equals this time, -b, which is going to be -3, over 2 times A, which is -1 over 28. So now we just need to simplify that. So that's going to give us -3 over 2 times -1 over 28 would be -2 over 28. 2 goes into both of those values. So that's going to simplify to -1 over 14. Now, remember, when we divide by a fraction, we're actually multiplying by its reciprocal. So this is just -3 times -14 over 1. And so -3 times -14 That should give us 42. Right, now, in the context of the problem, right, we found an S value. This is the speed where we're going to attain our maximum. Well, this S should be measured in miles per hour. And so this tells us that at 42 miles per hour, we're going to have our best gas mileage. Now, to find the actual gas mileage that we would get, now we need to substitute that S value back into our function. So we're looking for M of 42. I'm going to have negative 1 over 28 times 42 squared plus 3 times 42 minus 31. Okay. Now, at that point, I would just go to a calculator, right? Because I'm not going to try to square 42 in my head. And so if you were to put all of that in there, we should get 32. That's that value. And again, we need to think about the context of the problem. What are the units going to be here? Our M was measured in miles per gallon. So this right here is 32 miles per gallon. So what this tells us now is this new car attains its best gas mileage when traveling at 42 miles per hour, and that best gas mileage is 32 miles per gallon. All right, so that's all we've got for that section. As always, let me know if you have any questions. Send me those questions using the Ask My Teacher button in WebAssign when you have them. Drop in during student hours if you need to. Otherwise, have a great day, and I will see you next time.